This video is about inductors. An inductor is just a coil of wire which can store energy in the form of magnetic fields. An inductor produces these magnetic fields only when there is a current flowing through the inductor. The strength of the magnetic field highly depends on flowing through the inductor and the number of turns of the inductor. A straight conductor can also produce magnetic fields when current flows through it, but the density of these magnetic fields are quite low. But when we turn the conductor into a coil with certain number of turns, the current flowing through each turn creates its own magnetic field, which adds up to it jumps to its peak value. But the current flow increases from 0 to maximum at a very gradual rate. To understand this, we must know about Faraday's law of induction. Faraday's law states that if there is a changing magnetic field over a conductor, it will induce an electromotive force called an EMF in the conductor. The direction of this EMF is always opposite to the magnetic field which created it. Due to the property of opposing its own source of creation, this EMF is called back EMF. Here we can see that the induced EMF is directly proportional to the number of turns of the inductor and the rate of change of flux over a certain period of time, which is given as del phi by del t. The same condition occurs in this circuit. The only difference is that the source of the magnetic field. In the circuit, the magnetic field is created by the current flowing through the inductor. An inductor causes this lag in a DC circuit only during the switching periods, that is, only when the current value changes from 0 to its maximum value. As we have seen earlier, only a changing magnetic field can induce a back EMF in the inductor. So, at the beginning of the switching period, the current which is changing in magnitude creates a magnetic field which is also continuously changing in its strength, that is, expanding in nature. Due to this, a back EMF is induced in the inductor which opposes the cause for the magnetic field, which is the incoming current flow. This causes the lag of current through an inductor. When the magnetic field reaches its maximum strength, it can no longer expand and is no more changing in nature. So, the back EMF which was opposing the current flow disappears and allows the current flow through the inductor. Now the inductor behaves like a simple wire, that is, it does not oppose the current flow. An interesting thing happens when we open the circuit. Even after being disconnected from the voltage source, the inductor has some current flow for a brief moment. This is due to the energy which was stored up in the magnetic field of the inductor. The magnetic field is self-sustaining as long as there is current flow through the inductor. But once the current flow stops, the strength of the magnetic field decreases from its maximum value to 0. That is, the magnetic field around the inductor is changing in nature again. As a consequence, a back EMF is induced in the inductor, but this time it helps the current flow. The direction in which the magnetic field changes decides the polarity of the back EMF. This is why current lags behind voltage in an inductor. Hope you learned from the video. Subscribe and select the bell icon to see my future uploads.